Hello everyone, my name is Raghavi Priya, Assistant Professor, Department of Computer Science and Engineering. So in this video, you're going to see about the lecture series of the subject 23 CST 201 Database Management System, second year CSC, 4th semester. So unit 4, Transactions. So topic is Transaction Concepts, Asset Properties. So topics for discussion: transaction concept, need for transactions, asset properties, transaction states. So transaction concepts and asset properties. The core focus: understanding how database management systems guarantee that complex operations are processed reliably, safely and accurately. So the key framework is introducing the 4 fundamental pillars of transaction processing. So that is atomicity, consistency, isolation and durability. So gold standard reliability. So these properties ensure data integrity even in the face of concurrent users, errors or system failures. So empathize the unreliable system. So the scenario, so imagine transferring rupees 500 to a friend. So the system deducts the money from your account, but right before adding it to your friend's account, the server crashes. So the problem, so without transaction controls, your money is now lost in a digital void. So the database is in a invalid, corrupted state. So the impact, so loss of user trust, financial discrepancies and a system that cannot safely handle real world business operations. So define, so what is a transaction? Begin transaction, update, insert, select. So next there are 2 operations, that is commit and rollback. So definition, so a transaction is a single logical unit of work that consists of one or more database operations like insert, update, delete or select. So the boundary, it is bounded by a begin transaction statement and ends with either a commit success or a rollback failure. So the goal, to bundle multiple related steps together so the database engine can treat them as one indivisible package. Overview, the asset pillars: atomicity, all or nothing. The entire transaction succeeds or the entire transaction fails. So C, consistency, and I for isolation. So consistency ensures valid states. Isolation prevents concurrent user interference. So D stands for durability. So permanent and safe. Once saved, data survives system crashes and power outages. Atomicity, the all or nothing. So we have seen about the atomicity concepts. A transaction is indivisible if a transaction has 5 steps and step fails, 4 fails, the DBMS will automatically undo step 1, 2 and 3. So mechanism and isolation, the database uses the transaction log to track changes. If error occurs, it performs a complete rollback. So benefit, prevent partial updates that corrupt data and choose mismatched records. Consistency, the rule enforcer. The concept, the database must ensure that every transaction strictly follows all defined rules, constraints and triggers before it is allowed to save. So the mechanism, the DBMS checks primary keys, foreign keys, check constraints. Example, balance cannot be less than 0 and data types. The benefit, ensures that the data is always mathematically correct and conceptually valid. according to the business logic. So isolation, the invisible shield. So the concept, even 1,000 users are accessing the database at the exact same millisecond, each user transaction feels like it is the only one running. So the mechanism, the DBMS uses logging protocols, shared exclusive logs to block users from stepping on each other's toes or reading half finished data. So the benefit completely prevents anomalies like dirty reads, non-repeatable reads and phantom reads. So durability, serving the crash. So the concept, once the DBMS tells the user transaction successful via a commit, those changes are strictly permanent even if someone immediately unplugs. So the mechanism, write ahead logging. The database writes the confirmation to a physical non-volatile disk log before telling the user it succeeded. So guarantees absolute data survival against hardware failures, power outages and software crashes. Booking a flight, isolation and consistency. You select seat 14A, the database temporarily locks it so nobody else can claim it while you type in your credit card. Your card is charged and the seat is assigned to you. So your confirmation number is saved to the hard drive. Even if the airline's website crashes 2 seconds later, your ticket is safe. So assets quiz. So Q1, question 1, integrity constraint. So if a database enforces a rule that an account balance cannot fall below rupees 0 and a transaction attempt to withdraw the too much, so it is aborted. So the right answer is isolation. So indivisible unit. So which property ensures that a multi-step transaction is treated as a single unit, ensuring no partial updates remain if a mid-step error occurs? So the right answer is consistency. Next one is data survival. Which property ensures that once a commit is issued, the data survives even a catastrophic server power loss? Durability. So these are the few references. Check out with this. Thank you.